So this is week 68 quiz, and number one says, let A, B, and C be positive integers with A greater or equal to B greater or equal to C, such that A squared minus B squared minus C squared plus AB equals 2011, and A squared plus 3B squared plus 3C squared minus 3AB minus 2AC minus 2BC equals negative 1997. What is A? So we look at these two equations and we write them down because you can't really tell from the typing. So it's A squared minus B squared minus C squared plus AB equals to 2011, and A squared plus 3B squared plus 3C squared minus 3AB minus 2AC minus 2BC equals to negative 1997. And so our first instinct is just to add them up, because if we add them up, we just get a really symmetrical sum, which is just 2A squared plus 2B squared plus 2C squared minus 2AB minus 2AC minus 2BC. That equals 15. And this is a good sum because all the coefficients are 2 and there's one of each term. And so if we look at this and we try to factor it, because there's nothing else we can really do. And so we see that there's squares and they're AB, AC, and BC terms. So we'll just pair them up like A plus A minus. So if we pair them up like this one, wait, let me use highlighter for this one. So for example, we're gonna use this one, 1A squared and 1B squared. And we pair it up with, let's say, the 2AB term. And then we also do the 1C squared term. And we'll do 1B squared term. And we'll pair this up with the 2BC one. And finally, we have the 2A squared one. And I'll pair it up with the 2C squared one. And we'll have this go with the 2AC. And so we write this all down, we will get A squared minus 2AB plus B squared plus A squared minus 2AC plus C squared, and then plus B squared minus 2BC plus C squared, and this all equals 15. And then we see that these are just difference of like a square of a difference. So we just pair them all up and we get this and this, and so A minus B squared, A minus C squared, and B minus C squared. And this equals to 15. Oh, sorry, this is not 15. These are all 14, I just realized. And then we also know that these are all positive integers, so these squares also have to be positive integers. And so this has to be 9, this has to be 4, and this has to be 1. That's the only configuration of squares that'll work, that'll sum to 14. And so, obviously, because A is greater than B is greater than C, we know that A minus C will equal to, well, it's not, this thing's not necessarily in this order. So, like, it's obviously A minus C will be the greatest difference. So, this will equal to 9. And then, so now it doesn't, like, this could be 2 or 1, or this could be 1 or 2. I mean, I meant this could be 1 or 4, or this could be 4 or 1. So, like, this could be A minus B squared could be 1, then B minus C squared would be 4, and vice versa. Because we can't really decide which is which. And so we just do casework now. So we already know that A minus C equals to 3. Because we know that A is greater than C anyway. And let's just say that A minus B is, let's say 2. And we're just guessing here. We'll just do the other case if we have to. And we also know that B minus C equals 1 from this thing. And then, so we substitute everything for B. So we get A equals to C plus 3. A equals to B plus 2. And B equals to C plus 1. So if we substitute this into our first equation there, we'll see that, well, let me copy this real quick. Uh, shoot. Let me copy this real quick here. And now we can continue. So if we substitute everything in for B, then we get A squared. No, sorry. Since we know that A equals B plus 2, we get B squared plus 4B plus 4. And then, of course, minus B squared. And then C equals, oh, well, this is actually B minus 1 equals C if we want to substitute everything in as B. Minus B squared plus 2B minus 1. And then AB is just B squared plus 2B. And this equals to 2011. 2011. So we just cancel out all of the B squares here. And we're left with AB plus 3 equals to 2011. So you get AB equals to 2008. And we get B equals to 251. And so this is an integer, which is good. So that means that this case works. And we add this to A, because we want to solve for A. And we get 251 plus 2 equals 3. So, I mean, yeah, no, it's 253. So the answer is just 253.